Hi guys, here's another video about the CSS Pure Mathematics Exam from 2023. We are still in section B, and this is question 5, item A. So it says that given that u equals 1 over the square root of x squared plus y squared plus z squared, verify that uxx plus uyy plus uzz equals 0. So the problem asks us to verify that the function u satisfies Laplace's equation. So as we will see, this problem is just straightforward calculations of partial derivatives. So let us begin. So first, we write u in a convenient way. So this expression is the same as this one. It's the same as x squared plus y squared plus z squared to the power minus 1/2. So now we calculate the partial derivatives. So here I'm just gonna focus on partial u, partial x, because the other ones are the same. So here, let's take partial u, partial x. So what I do here, I just use the chain rule and the derivative of a power. So in order to derivate this expression with respect to x, so first I had a minus 1/2 here, so I put it down. I get minus 1/2 of the expression I had, and minus 1/2 minus 1 is minus 3/2. So this is why I get this minus 3/2 here. And since I'm calculating the derivative with respect to x, by the chain rule, I have to multiply the expression by the derivative of this expression here with respect to x, which is 2x. So hence this 2x here. And so this 2 cancels with this 2 I had here in the denominator, and I get this expression here, minus x times this expression, x squared plus y squared plus z squared to the power minus 3/2. So, and for the other partial derivatives, for partial u, partial y, and partial u, partial z, the calculations are almost the same. The only thing that changes is that when I apply the chain rule, since I'm calculating the derivative here with respect to y, I get this term 2y here. And for partial u, partial z, when I get the derivative with respect to z, I would multiply by this 2z here. So I get this expression for y, for the derivative with respect to y, and this one for the derivative with respect to z. Now, I have these three expressions, and I'm going to calculate partial derivatives of them. So I'm going to focus on the first one, ux, because the other ones are almost the same as in this case. So I look at this expression, and here we have a product. So I have the product of the function minus x times this expression here, x squared plus y squared plus z squared to the power minus 3/2. So I'm going to use the product rule. I want to find the derivative of this expression with respect to x. So I'm going to use the product rule. So I obtain this. So first, since I had minus x, the derivative of minus x with respect to x is minus 1. And I repeat the second expression I had. Then I repeat minus x, and I find the derivative of this expression here with respect to x. So I have here a minus 3/2, so I put it down, minus 3/2. Minus 3/2 minus 1 is minus 5/2. And again, the chain rule, I have to find the derivative of this expression with respect to x, which is 2x. Now, this 2 cancels with this 2 here. This minus with this minus becomes a plus. So I get this expression here. And this expression can be rearranged in order to simplify things to make this expression. So it's not hard, it's only plain calculations. And for the other partial derivatives, they're almost the same. So I won't dwell much in the calculations. They're pretty much the same. The results I get, so when I'm finding uxx, I get first 2x squared minus y squared minus z squared over this denominator here. When I'm calculating uyy, I get first 2y squared, then minus x squared minus z squared, the same denominator here. And when I'm finding UZZ, I get 2z squared minus x squared minus y squared over the same denominator. And now all I need to do is add these expressions up and see that in the end they all add up to 0. So I get this. I add the expressions up, and since they are over the same denominator, I get this big numerator here. And now I just observe that this 2x squared cancels out with this minus x squared and this minus x squared here. This 2y squared cancels out with this minus y squared and this minus y squared here. And this 2z squared cancels out with this z squared and this z squared here. So we get 0. And just as a brief comment, you can, if you look at my calculations, I didn't bother to put the point at which we are making the calculations, so the notation was cleaner. So they are taking, all the partial derivatives are taken in an arbitrary point, and x, y, z in R3, which is not 0 because the domain of the mapping excludes the origin of R3. So that's it for today. I hope you enjoyed the video. Please give me a thumbs up, subscribe to the channel, and leave me a comment so I can know what you think about the video. Thank you very much. Bye.